let's consider a particular classical secret sharing protocol and see where does the vulnerability really lie in the quantum era. Uh, One example of a secret sharing protocol is Shamir secret sharing protocol. In this case, the secret is hidden in a polynomial such that each participant holds one or few points in that polynomial, and only if enough points are put together can you reconstruct the polynomial. Otherwise, you might be overfitting, underfitting. You will not be able to reconstruct the polynomial without enough points that can be put together. So this is an example where one can prove that the security is information theoretic, in the sense that the threshold that is defined if the number of points or number of shares are less than the threshold, you do not have enough information to reconstruct the secret. And this threshold security, which is information theoretic, cannot be broken by quantum computers either. So where does the vulnerability really come into picture? We are aware that quantum computers that are running Shor's algorithm in the future can break RSA, elliptical curve cryptography, or Diffie-Hellman, all of these classical encryption protocols. So whenever the dealer who wants to distribute the secret shares to different participants uses classical encryption to distribute them, that is where we can anticipate the vulnerability to lie. So eavesdropper can, in fact, save some of these shares or all of these shares by intercepting, and at a future date, they can decrypt them when they have access to quantum computers that can run Shor's algorithm. So this opens up this harvest now, decrypt later attack, which is possible during transmission, and it is the transmission of the secret shares that poses the vulnerability in classical secret sharing protocols when we consider how they would flare in the quantum era. So how do we go ahead and resolve this? How do we enhance security of classical secret sharing protocol? We can do this by using quantum key distribution, and we have talked about different protocols for quantum key distribution in the past webinars, and they are quite popular in today's literature as well. These could be BBM92 entanglement-based, or BB84 prepare and measure protocol, or Eckert-91 entanglement-based protocol. In all these cases, how does this get integrated into secret sharing approach? The dealer runs QKD with each of the participant set, and they generate keys that they have in common, and they use those keys to encrypt the classical share. And this way they can send the share or distribute the share securely, and all the vulnerability around harvest now, decrypt later attack is taken care of. So this is ensuring information theoretically secure transmission, and in this manner, the classical secret sharing protocols can be made quantum safe.